Hello again, welcome to the shop. This is Randy. Today we're going to be working on part 4 of the small block Chevy cylinder head rebuild, where I will be talking you through the reason we back cut the valves after facing them, and checking the seat contact in the head, and be explaining why you need to check the installed height of the valve in the cylinder head, and checking spring pressures, and I'm at a loss. But anyway, we'll bring it back over to the bench and I'll do a little bit of explaining, and then we'll go and start checking some springs. See you in a bit. Bye-bye. This is the intake valve that I back cut. I didn't show that. It's pretty much basically the same procedure as the facing the valve that was in a previous video, but this is your seat on the face of the valve, where the valve hits the seat in the head. The area I'm talking about is the area just below that shiny ring that's around the valve. That is a 30-degree back cut on the underside of the valve. All that does is it helps the air go around the valve, because the valve is in the head like this here. It helps the air, because air is coming up, it helps air flow out around the edge of the valve. Otherwise, what you're going to have is a sharp edge right there on the underside of this valve if you didn't undercut this. And from my experience, with just a single cut on the valve and a single cut on the seat, no 30-degree top, no 60-degree bottom cut on the seat, you're probably looking at 25 to 35 horsepower difference by not doing it, versus doing a 45-degree seat on the valve seat in the head, doing a 30-degree top cut, a 60-degree bottom, and then undercutting the valve below the face of the valve where the valve hits the head 30 degrees, and that's basically free horsepower for just a little bit of work, and that's pretty much everything that I do on every motor. So that explains that. This right here is the cam card that you're going to get when you buy your camshaft. It's all manufacturers of camshafts supply you with a cam card. It gives you the part number, tells you if it's a solid roller camshaft or a solid lifter camshaft. It'll give you your valve adjustment clearance, 20 thousandths on the intake, 22 on the exhaust on this one. Tells you your gross valve lift, the duration. This is generally their advertised lift. When you're looking up a cam, the advertised lift is 312 on the intake, 322 on the exhaust. The actual duration is measured at 50 thousandths of lift. That's 276 degrees on the intake, 284 on the exhaust. This is your lobe lift at the cam. It tells you how much the lifter is moving at the camshaft. And this is your lobe separation angle. The other thing I wanted to point out is this number right here. The cam manufacturer will give you a part number of their valve spring that they recommend for that camshaft, and then you go to the camshaft book and you look up that spring, and they will give you all the specs for that spring, the installed height, what the spring pressure should be at the installed height, the rate of change versus as the spring compresses. It'll give you coil bind, It'll tell you spring pressure at maximum lift. Very, very valuable tool. And it's all these things together is what makes the engine combination run the way it runs. And we'll bring you right back here in a minute. I'm going to be over at the valve spring checker, and we'll start explaining some of that. All right, we're back at the camshaft book here in the valve spring section on the camshaft. This is the part number 938. It gives you the outside diameter, the inside diameter. Here's your installed height, 203 pounds at 1'9". Open load is 567 at 1" 350. Your coil bind is 1" 225. This is your rate, pounds per inch. Tells you what retainer you need. If it's a titanium retainer or a steel retainer, I always use titanium retainers just to try to keep as much weight off the valve train as possible. It'll tell you what spring cup or spring locator that you need. The locator is a cup that fits in the bottom of the cylinder head around the valve guide, and that protects the aluminum head from the spring, because the spring on aluminum will just eat right into the aluminum itself. And it also gives you a spring number. So you can find this online, or I have books that I have. This is comp cams. I've got Crane, I got Iskey, I got Crowler. But all the books and online, you can find all this information for all the springs that they have. This is gives you the basic information for the part number, and there's more parts in here where they show you for certain installed height what the pressure should be. It's all in the manufacturer's book, or you can find it for each cam manufacturer online. Okay, what I have here is one of the titanium retainers, and what you need to do before you start measuring the springs is you need to measure this top land here on the retainer. You need to measure the thickness of that, and that is 104 thousandths. So they want your spring height checked at 1'9". Turn this on here. That's 0, and this reads your height right here. Bring this down till it just touches the scale. Okay, we're just touching. Zero that, and we'll zero this. Now what we have to do is we have to take a spring, put the retainer on the spring like such, slide the spring in here, and so we have to add 104 thousandths to our number. So instead of reading 1'9" here on the scale, it's going to be 2" 4 thousandths. That's because of the thickness of the retainer. Bring this down here. 2" 100, 2" 50, 37, 13, 9, 7, 6, 5, and 4. 2" 4 thousandths. And this particular spring is 263 263 pounds on the seat. And if we back that up a little bit, we'll go to a 2-inch 50 thousandths. It's 234. Let me grab another spring here. We'll check another spring. I'm going to grab a spring out of a different box. I'm just showing you an example here. Be right back. I got another valve spring with the titanium retainer on it, the same titanium retainer as this. Same OD on a spring, inch 550. The ID is the same. You've got an inner spring with a damper and an outer spring. Coming up on 2-inch 4 thousandths. And this particular spring here measures 125.6. So these springs here are actually for a solid lifter camshaft, but non-roller. And this set of springs here are the springs that will be going on the small block Chevy heads, but I don't have a 1-inch 900 installed height. I have a 2-inch installed height. So we'll measure this again here at 2-inch 4 thousandths. Actually, it's got to be 2-inch 104. 2-inch 104. We're at 201 at a 2-inch installed height, and they recommend a 203 pound install height for the spring pressure when the valve is closed on the seat. So we're going to mark this spring as number 1. Number 1, I got a rough chart here. This is head 1, the intake and exhaust. Number 1 spring is going to be 202. 202. So we take this spring out, and I have a box here that I marked inside with all the numbers. And this spring is going to go in position 1, and that way I can look at my chart here, and I know that this spring is rated at this pounds at 2-inch install height, and so on down the line. And I'll bring it back as soon as I'm done checking them all. Be right back in a minute. All right, we're back over at the cylinder head with 2 of the valves. The valve I numbered, probably aren't going to be able to see that real well, but the valves I've all numbered. This is number 1 intake, and the cylinder head I took a stamp and stamped on this exhaust port here. This is number 1 right down here. So we're going to take this valve, put it in the head like so. I have a 30,000 shim down in the head right here, and this is basically a telescoping micrometer. You can see it has graduation numbers on it, and as I screw it down, there's inch 900 right there, and that would be inch 800 right there. So I'll screw this back up Put this in the head like so, put a retainer on it, and then you take valve locks. This is a 10-degree valve lock, which the reason I use 10-degree valve locks is it's a bigger wedge that fits down in the retainer here. A bigger wedge that fits down in the retainer. There's one. And here's the other one that fits in there like so. And the thought process between having a bigger wedge, if you use the most common is a 7-degree lock. A 7-degree lock, when you get lots of spring pressure, it can pull through the taper on the retainer, and then all kinds of destruction happens. We'll put that on there like that. Put our locks in. The groove on the valve like so. This one here like that, and pull this back a little bit. Use a retainer to hold the locks in place, and start unscrewing the height gauge. When it gets tight, what I do is I give it a couple of taps with a plastic hammer just to make sure it's seated good, and then we read our number, and our number is at looks like just under 1 inch, 990, about 187. 1 inch 987. We're shooting for a 2-inch install height on this particular valve. You're not going to get it perfect. If you're within, 10 or so thousandths either way, you can make that up with some shims. But I prefer to have it a little bit tight, because the valve springs, when they get hot, when they get some heat in them, after they've been run for a little bit, the spring will relax a little bit. So if we start with a little bit higher installed spring pressure, that's not a bad thing. So we're going to take and write this down. Intake number 1 is 1 inch, 1.987. Go through and check all the install heights of all the valves, and I will bring you back. All right, I'm back. I got all the valves put in the head. I checked all the install heights. Did the last exhaust valve on number 7 cylinder, and take this back off here. Take the locks back out. And what I came up with on my measurements here is 1 inch 987 on number 1 intake, 1 inch 970 on number 1 exhaust, 1 inch 987 on number 3 intake, 1 inch 985 on number 3 exhaust, 1 inch 995 number 5 intake, and 1 inch 982 on number 5 exhaust, 1 inch 985 on number 7 intake, 1 inch 982 on number 7 exhaust. So with that being said, what you want to do, number 1 intake spring was 202 pounds. Number 2 intake spring, or number 2 spring, was 204 pounds on a seat. Number 3 was 206. Number 4 was 210. Number 5 was 210. Number 6 was 211. Number 7 was 208. And number 8 was 203. So generally what I try to do is I put the stiffest springs on the intake valves, because the intake valves are bigger and weigh more. So you're going to want to start with a little bit more pressure there. So I'm going to put number 5, number 7, and number 4 and number 6 springs on the intakes. The rest are going to go on the exhaust. I'll pull the valves back out, lubricate them, and then we'll put some valve seals on, and we'll start installing the valve springs. Bring it right back. Okay, I'm back. While I was looking for valve seals, I happened to find some 7-degree valve locks to show you the difference between a 10-degree and a 7-degree lock, as to why the 7-degree lock is not as good. This is a 7-degree lock here versus the 10-degree. And you can see why, with high spring pressure, why the 7-degree will sometimes pull through the retainer. Just a little bit of an explanation of what's what. And we got the valve seals here. And this is the installer. I made that out of a piece of round aluminum. The seal just fits in like that there. And you take and push the seal over the top of the valve. Take your plastic hammer, tap it on, and it's installed just like that. Do the rest of them here, and then we'll start putting the springs on. I did take and pull all the valves out of the head and take some 30 weight motor oil and spray on the stem of the valve, and then I put some in the guide, put the valve in, and worked it back and forth just to make sure that the valve guides are lubricated good. All right, grab this retainer here, and we're going to take number 5 spring, which is 210 pounds, and we're going to install that on number 1 intake. Number 1 intake valve, which is right here. Start cranking down the handle until the valve pokes through the retainer, like such. And put your valve lock in. Make sure it's in the groove. Take the other one. Make sure it's in the groove. Like that. Use my thumb to hold them both in place. And start releasing the spring pressure. Oops. That one fell out. We'll go back a little bit here. Might not have to. Nope. Good. Just like that. Back that screw off with the spring compressor. Give it a couple taps with a plastic mallet, and that's it. The spring is installed, the seals are in, all the installed heights are checked, and I'll bring you back in a little bit as soon as I have all the springs on. Be right back. All right, I got the plate set up on here on the head. I put an old spark plug in the plug hole, and we're going to start filling this up. I want to go slow so that it doesn't burp out all over the place. And we're just about there. Lift this end up here. Get that last little bit of air to burp out. Okay, where are we at here? We are at 67 cc's. It was 65.5 before, so it took about cc and a half of material out of the chamber, and made the chamber a little bit smaller after machining the head gasket surface. But I have to refigure the compression ratio now with it recalculated. But like I said, I think the benefit of having the chambers blended perfectly, a lot better than what they were before, with the valves sitting down in basically a bowl, all shrouded by the combustion chamber itself. This is actually going to be a better deal. But and that there will pretty much conclude the rebuild of these cylinder heads. I'm Got the other head put together here. I'll get that finished, and we'll see you when crankshaft, rods, and pistons get back, and we'll start final assembly. Till then, have a great day, and we will see you later. Bye-bye.